So what are alkynes? So these are unsaturated hydrocarbons which contain at least one triple bond between carbon-carbon atoms. So under common naming system, compounds belonging to alkyne groups are named as derivatives of acetylene. For example, methyl acetylene, that is CH3C triple bond CH. Preference to substitution reactions were given instead of addition reaction. So these features were later explained by the resonance theory. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to continue the chapter Hydrocarbons. So in the previous session, we have learnt about alkenes, their nomenclature and isomerism, the preparation of alkenes, and then physical and chemical properties of alkenes. So in this session, we are going to study about alkynes, again their nomenclature and isomerism, preparation of alkynes, then physical and chemical properties of alkynes, also about aromatic hydrocarbons, which is also called as arenes. So what are alkynes? So these are unsaturated hydrocarbons which contain at least one triple bond between carbon-carbon atoms. So the general formula of this alkyne is CnH2n-2. Again, N represents number of carbon atoms. So the first stable member of the group is ethyne, having a formula C2H2. Common name for the ethyne is acetylene, which is a simplest alkyne. Also, it is a colorless gas with a slightly sweet odor. So what are the uses of alkynes are? We shall see one by one. So oxyacetylene flame, which is actually acetylene plus oxygen, is used in arc welding and cutting metals like at very high temperature flame. So it is used as a starting material for preparation of many organic compounds like alcohols, aldehydes, acids, polymers, etc. So the carbon atom of the triple bond undergo sp hybridization. The two sp hybrid orbitals are diagonally opposite to each other, so it results in linear structure. So if this is the structure of ethylene, so there is a triple bond between carbon-carbon double bond and hydrogen is associated next to the carbon. So the geometry of this structure will be linear, that is 180 degree. So let us see what is the nomenclature of alkynes or how is it represented using IUPAC system as well as common naming system. So under common naming system, compounds belonging to alkyne groups are named as derivatives of acetylene. For example, methyl acetylene, that is CH3C triple bond CH. And IUPAC name for the same structure is propyne. So for common naming, we will have to use acetylene word. And under IUPAC system, it is derived from corresponding alkanes by replacing ANE, that is last three letters, by YNE. Numbering rule, the position of the triple bond is given by the smaller number of the two carbon atoms involved. And therefore, first the carbon member is ethyne, we know, and when you go higher and higher, we will have to consider this as the smallest number, because as the rule says, carbon-carbon having triple bond should be given a smaller number. So it is prop-1-ine. Now let us see some other alkyne groups. So it is C2H2. The structure is C triple bond C, and remaining hydrogens are being added to carbon and carbon, satisfying the tetravalency of the carbon. Trivial name is acetylene and IUPAC's name is given ethyne. So formula having C3H4 is CH3C triple bond CH, and the name is methyl acetylene and the IUPAC name is given propyne. C4H6 compound formula is CH3CH2C triple bond CH. Then as I said, common name should be having a derivatives of acetylene. So it is ethyl acetylene and IUPAC name is given but-1-ine because it consists of 4 carbon atoms. Compounds having the same formula, that is C4H6, can be written in a different way, that is called a structural isomer. So triple bond is present between carbon 2 and carbon 3. So therefore, it is dimethyl acetylene, common name, and the IUPAC name is but-2-ine. Because triple bond is between C2 and C3. So the lowest possible number should be given for the IUPAC naming. So next we'll see how are alkynes prepared In that, ethine is an example that has been taken. The first one is from calcium carbide. So this is basically an industrial method. So the first step involves the preparation of quicklime from limestone. That is, the formula is CaCO3, calcium carbonate. On decomposing, it gives calcium oxide plus carbon dioxide. So the second step involves formation of calcium carbide. So calcium oxide, when it undergoes reaction with carbon in an electric furnace, it gives calcium carbide plus carbon monoxide. Then the third step involves reaction of calcium carbide with water, which produces ethine. So the reaction is calcium carbide, that is CaC2 plus water, gives ethine and then calcium hydroxide. So this is how the ethine is prepared using calcium carbide. So the second one is using vicinal dihalides. So what are these vicinal dihalides are? Those are dihalides where two halogen atoms are on the adjacent carbon atoms. So let us see with the example later now. So the first step involves, that is, dehydrohalogenation with alcoholic potassium hydroxide. So here in this step, it will be a removal of one hydrohalide to form alkynyl halide. So here CH2Cl and CH2Cl is the compound. So on removal of hydrogen chloride using alcoholic potassium hydroxide, we will get alkynyl halide. So the second step involves the treatment with sodamide having a formula NaNH2. Here it removes another hydrohalide to form alkyne. So there is only one hydrochloric acid here in this compound. So it will be removed using sodamide forming ethine. So that was about how to prepare alkynes using different compounds. Now let us study about properties of alkynes. Under that, physical properties involves state, color, odor, polarity, density and trends with molar mass. So we'll see one by one. So state of different alkyne groups are, first three members are gaseous state, that is ethine, propyne and butane. Then after that, next 8 are liquid in state. Then higher members of alkene groups are solids in state. Then what about their color and odor? All alkynes are colorless. Ethine has a characteristic odor and others are odorless. So ethine has got sweet characteristic odor. So that is about color and odor of the alkyne group. Now polarity, it is again weakly polar in nature. Density and solubilities, alkyne groups are usually lighter than water and they are insoluble in water. Alkyne groups are mostly soluble in organic solvents like ether, carbon tetrachloride or benzene, etc. Now how does it go with the trend with molar masses? Melting point, boiling point and density increases with increasing the molecular mass. As you go higher in the alkyne group, melting point, boiling point and the density will increase. So let us now study about chemical properties of alkynes. So first thing is addition of dihydrogen. So this process is also known as hydrogenation. So here in this process, when ethine is heated with hydrogen in the presence of nickel, platinum or palladium catalyst at 250 degrees Celsius, ethane is formed. So ethine is reacting with hydrogen wherein one of the pi bonds are broken down by the hydrogen gas forming ethane. So the second one is addition of bromine to propyne. It goes step by step. So here in the propyne, one of the bromine molecule is going to attack the propyne. That is, one of the pi bond is being broken down by the bromine molecule forming 1,2 dibromopropane. Again, this further step is being involved forming 1,1, 2,2 tetrabromopropane. So this is how the compound is formed using ethine. So the third one is addition of halogen acids to alkynes. Here alkynes react with halogen acids according to the Markovnikov's rule. So this is a general equation of alkyne reacting with halogen acids. Here halogen will attack the second carbon atom forming 2 haloalkene, and then again one of the halogen acids will attack the second carbon atom again to form 2,2 dihaloalkane. Example, ethine reacts with HBr to form bromoethane and finally it forms 1,1 dibromoethane. So the reaction involves ethine, this is the ethine formula, that is C triple bond C and H on both the sides. Then hydrogen halide is HBr. So this halide Br is going to attack the second carbon atom, forming bromoethane. Then again, one of the hydrogen halides will be added to this compound, forming 1,1 dibromoethane. So addition of water. Here alkynes are immiscible in water, that means it is not going to form a miscible liquid. So, but when an alkyne is passed through dilute sulfuric acid in the presence of mercuric sulfate at 333 Kelvin, addition of one molecule of water takes place to form carbonyl compound. So, in the presence of sulfuric acid, one of the water molecule is going to react with alkyne to form alkenol. On tautomerism, it results in the formation of ketone. So, when you go for the reaction, having an example, that is alkyne example is generally we take ethane. So, in the presence of dilute sulfuric acid, it forms water molecule. So, that is going to add up to give ethanol. Then on tautomerism, it is going to result with a formation of ethanol, that is CH3CHO, an aldehyde group. So, the next one is polymerization reaction of acetylene. Acetylene undergoes polymerization on heating in the presence of catalyst, and the nature of products depend on the condition of polymerization. So, there could be two possible polymerization. One is linear polymerization and another one is cyclic polymerization. So, under linear polymerization, acetylene undergo linear polymerization to form polyacetylene under suitable condition. So, as I told, N represents any number of acetylene group. So, undergoes polymerization to form polyacetylene. And under cyclic polymerization, when ethane is passed through a red hot iron tube, it polymerizes to form benzene. So, let us see with the general reaction. There are three ethane molecules. One of the pi bonds are broken down to form a bond between each carbon atom under red hot iron tube. So, therefore, it forms benzene, which is of a cyclic in nature. So, that was about alkynes. So, now we shall study about aromatic hydrocarbons, which is also having a name, arenes. Now, what are these aromatic hydrocarbons are? These are hydrocarbons that contain a benzene ring or similar unsaturated hydrocarbon system that are called aromatic hydrocarbons or arenes. The term aromatic is derived from a Greek word meaning a pleasant smell. That is because many of the such compounds were first identified as pleasant smelling substances. So, these aromatic compounds are being named after that. So, what are the characteristic features are? Most aromatic hydrocarbons contain benzene ring. Then benzene ring is highly unsaturated, and yet in most reaction the unsaturation is retained. So, that means cyclic nature is retained. This unusual stability is due to delocalization of pi electrons. Therefore, unlike alkenes and alkynes, benzene usually undergoes substitution reaction instead of addition reaction. Now, what are the types of aromatic hydrocarbons? There are two types basically. One is benzenoid and another one is non-benzenoid compound. Benzenoids are those compounds containing a benzene ring. For example, benzene, toluene, naphthalene or biphenyl. Benzene is normal C6H6. A methyl group attached to benzene ring is called toluene, and two benzene rings attached to each other are called naphthalene, and there is a bond between a benzene ring again, so it is called biphenyl. So, all these compounds consist of a benzene ring, so they are named as benzenoid compounds. So, under non-benzenoid compounds, aromatic compounds do not contain a benzene ring, but it consists of a cyclic structure. So, such compounds can be given as example is furan. You can observe here there is no 6 carbon atoms, but it is in a cyclic structure wherein oxygen is attached in the cyclic structure. So, now let us see what are the characteristic features of benzene ring. So, structure of benzene, it was proposed by Kekulé, is a scientist. He proposed a hexagonal ring of 6 carbon atoms with alternating single and double bonds, each carbon attached to one hydrogen atom. So, there are 6 carbon atoms with alternate single and double bond. One here double, single, double, single, double and single. So, there are alternate single and double bonds, and these carbon atoms are attached to one hydrogen atom. Or simply this structure can be written as this way. So all these bonds are closed. There is no mentioning of carbon and hydrogen. So what are the limitations of this benzene ring or our Kekule's model is, it could not explain the stability of the benzene ring. Preference to substitution reactions were given instead of addition reaction. So these features were later explained by the resonance theory. So it was only given the structure, that is having C6H6, but was failed to give explanation about stability as well as the reaction between the molecules. Now we'll see what is that resonance structure of benzene. So resonance structure involves the structure A. You can observe there is an alternate double bond and a single bond between the carbon and carbon atom, but this can also be written in this way, where double bond is been present over here, where in single bond is given in the first structure. So alternatively single and double bonds are placed, and this structure is also equivalent to the structure having hexagonal ring with a circle in between. That shows that is delocalization of pi electrons are happening inside the structure. Or benzene ring can also be represented by hexagonal ring and a small circle in between. That also is the correct structure for the benzene ring. And this benzene consists of sp2 hybridization. So there are 6 carbon and carbon sigma bond and 6 carbon and hydrogen sigma bond and 3 pi bonds. So totally it makes up to 12 sigma and 3 pi bonds between carbon and hydrogen atoms. So now let us see how to prepare benzene using various methods. So first one is from using coal tar. So this is actually a commercial method wherein benzene is obtained by fractional distillation of a coal tar. So this is mainly industrial source. Second thing is laboratory method, wherein it involves cyclic polymerization of ethine. When ethine is passed through a red hot iron tube at 873 Kelvin, 3 molecules polymerize to form benzene. So 3 molecules of ethine is going to form a benzene, that is C6H6. Okay, second one involves decarboxylation of aromatic acids. Decarboxylation represents removal of carbon dioxide. Here sodium salt of benzoic acid is going to react with soda lime to give benzene and then sodium carbonate along with the removal of carbon dioxide from the sodium salt of benzoic acid. Second one involves reduction of phenol, that is vapors of phenol are passed over heated zinc dust to give benzene. That is phenol is nothing but C6H5OH, benzene ring consisting of OH group. Then when it is passed over zinc, it is going to form benzene along with that zinc oxide. So that was about preparation of benzene. So in the next session, we shall learn about physical and chemical properties of aromatic hydrocarbons as well as carcinogenicity and toxicity. Thank you.